Hello friends and welcome to Studi.Live. Let us start with our topic of continuity, and today we are going to start with the level 1 questions of continuity. So in this, the questions are going to be quite easy, but they are the questions which are very much important for your board exams or college exams, where these questions can definitely be asked. Okay. And of course, this will be like your building blocks for your level 2 and level 3 questions. So understanding level 1 questions is quite important. Okay. Once you understand level 1 questions, then we can go to level 2 and level 3, understand them as well. So what is the question over here? Examine whether the function is continuous at the point indicated against them. So over here the question says for x equal to 1, we have to check whether the function is continuous or not. So the function given is f of x is equal to x square plus 18x minus 19 upon x minus 1. When x is not equal to 1 and when it is equal to 1, it is given to be equal to 20. So of course we will have to check the limit. Let us find the limit when x tends to 1 f of x. So what is limit x tends to 1 f of x? So limit x tends to 1 f of x is of course x square plus 18x minus 19 upon x minus 1. Okay. So this is the limit. So let us solve this. So of course we will factorize the numerator and then apply the limit so that we can get the answer. So this will be equal to, okay, so limit x tends to 1, okay, x square. So the factor will be of course plus 19x minus 19 upon x minus 1. So this is the factor that we will have. So this is limit x tends to 1. I can take x common, I will be left with x plus 19. Minus 1 common, we will be left with again x plus 19 upon x minus 1. So this is what we are getting over here. So of course I can take x plus 19 as my common term for the numerator. So I will get limit x tends to 1, x plus 19, and this is x minus 1 upon x minus 1. So of course we can cancel off the terms x minus 1, correct. So we can cancel off the term x minus 1. This can be cancelled because x is not equal to 1. That is the case when we are solving the limit. Okay. So over here we can see that this definition, this rational function was for x is not equal to 1. So definitely x is not equal to 1, but it is very close to 1. So we can apply the limit to be equal to 1. Okay. So if I apply the limit now at this step, okay, so when I apply the limit, so applying the limits, okay, so applying the limits. So of course in the place of x we will be substituting it as 1. So I can say this is equal to 1 plus 19, which is equal to 20. So over here we can see that the function value was also given to be equal to 20. So definitely we can say therefore limit x tends to 1 f of x is equal to the value of f of 1. So the limit value is equal to the function value. So therefore the function is continuous at x equal to 1. So this is how it is. So hopefully this question is clearly understood by everyone. Let us now go to the next question. Hello friends, let us now continue with this next question. So the question again says examine whether the function is continuous at the point indicated against them. So we have been given two functions. You can see at the first function, that is a cubic function when it is less than or equal to 2, and it is a linear function when it is greater than 2. So of course at the point 2 we will have to check whether the function is continuous or not, because of course before 2 it is a cubic function throughout, so it is definitely continuous, and after 2 it is a linear function which is of course unbroken, so that is also continuous. So what happens at 2? So let us find the left hand limit and right hand limit in this case. Why? Because we have a function which is less than 2 and greater than 2, it has a different definition. So we will have to check the left hand limit and the right hand limit of the function. So let us find the left hand limit. So limit x tends to 2 minus f of x. So when I am saying x tends to 2 minus, that means we have to use the function where it is written less than 2. So where it is written less than 2, it is x cube minus 2x plus 1. So it is x cube minus 2x plus 1. Let us substitute the value of x to be equal to 2 because there is no term at the denominator, so definitely we can just apply the value. So this is 2 cube minus 2 into 2 plus 1. So this is equal to 8 minus 4 plus 1. So 8 plus 1 will be 9, 9 minus 4 will be 5. So this is the value that we are getting. This is the left hand limit that we have just got. Now let us check whether it is, okay, whether the same value is coming for the right hand limit. So limit extends to 2 plus f of x. So this is now going to be equal to limit extends to 2. Now we will use the value of function which is greater than 2. So for x greater than 2, what is the definition of the function? It is 3x minus 2. So this is now 3x minus 2. So this is limit extends to 2. Okay, let us directly apply the value of x to be equal to 2 because the denominator is again 1, it is not 0. So we can directly apply the value. So this is like 6 minus 2. So no need to write limit over here. So this is 6 minus 2. So that is coming out to be equal to 4. But over here this value was 5. So what are we getting over here is that limit x tends to 2 minus f of x is not equal to the limit extends to 2 plus f of x. So definitely, since the limit values are also not same, the function is discontinuous at the value of x equal to 2. So we can say therefore, the function is discontinuous at x equal to 2. So this is how we have to solve such a question when it is less than and greater than. If it is just like not equal to and equal to, we just have to find only one limit because that is the definition that is used throughout the function. But for one point, it is not defined in that same manner. So we have to discuss the continuity by using not equal to and equal to. So for that, we will be using only one limit and one function value. Over here, we had to find the left hand limit and right hand limit because we had two separate definitions for less than and greater than. So hopefully this question is now clearly understood by everyone and you are able to like understand how the limits are found. When we find left hand and right hand limit is also clearly understood. So hopefully this question is clearly understood by everyone. Let us now go to the next question. Hello friends, and let us continue with our topic of continuity. So over here you can see the question, show that the following function have continuous extension to the point where the function is not defined, also find the extension. So over here you can see that the question is of the type not equal to, x is not equal to 0. So whenever a question is of that type, definitely we can say that the function has a removable discontinuity at that point, if at all it is discontinuous. Now over here we have not been given the value of x to be equal to 0. So definitely whatever is the limit value is the value of the function, so that we can say that the function is continuous. So when we are saying that it has a continuous extension, that means for the value x equal to 0, if I define the function to be the limit value, then definitely I can say the answer will be equal to what, okay. So in this case, what we have to do is, okay, so show that the following function have continuous extension to the point where the function is not defined. So what we will do is we will find the limit when x is not equal to 0 or limit extends to 0, correct. So we will find the limit for x tends to 0 and whatever is the answer, we will take that to be the function value and definitely the function will become a continuous function. So that is what we have to do. So let us find the limit, okay. So let us find the limit when x tends to 0. So limit x tends to 0. So this is the value of the function, of course, limit x tends to 0 of f of x. So limit x tends to 0. So this is 3 sine square x plus 2 cos x into 1 minus cos 2x upon, this is 2 into 1 minus cos square x, okay. Now this is slightly different, 1 minus cos square x. So let us apply the formulas that is known to us, okay. So let us apply the formulas wherever it is possible. So I can say this is limit when x tends to 0, okay. So this is 3 sine square x plus 2 cos x Now, what is the formula for 1 minus cos 2 theta? 1 minus cos 2 x. 1 minus cos 2 theta is 2 sine square theta. So, this is 2 sine square x that we will get upon, this is 2 into 1 minus cos square x, which is also equal to sine square x. So, this is also equal to sine square x. We can see that we can take sine square x as our common term. So, we can see sine square x is common. So, limit x tends to 0, we can take sine square x as our common term. So, this will be 3 plus 2 cos x. Of course, we will be left with 2 over here. So, it is 2 into 2 cos x upon this 2 sine square x. So, what can be cancelled in this case? Okay. So, definitely sine square x and sine square x can be cancelled, correct. So, we can cancel off the term sine square x, whatever is left, we can apply the limit for that. So, let us apply the limit in this part now. So, when I apply the limit in this case, this will be 3 plus 2 into 2 cos 0, correct. So, this is cos 0 upon this is 2. What is cos 0? Definitely that is 1. So, we are left with 3 plus 2 2s are 4 into 1, 4 into 1 will be of course 4. So, this is the answer that we are getting 7 by 2. So, this limit exists. That is enough to say that there is a continuous extension for the function. So, this limit exists, okay. So, we can say therefore we can find a continuous extension. So, continuous extension of the function at x equal to 0. So, we can find a continuous function, okay. We can find the continuous extension of the function at x equal to 0. The function can be redefined as, or function is defined as. So, the function that should be defined for the function to be continuous, okay. So, the function has to be continuous, then it should be defined as like this. So, it is 3 sine square x plus 2 cos x. So, this was 3 sine square x plus 2 cos x into 1 minus cos 2x upon 2 into 1 minus cos square x. So, this is how the function was when x is not equal to 0, and for the function to be continuous at x equal to 0, its value should be taken as this value that we had obtained right now, that is 7 by 2. So, this is the function that it should be defined as, so that the function becomes a continuous function. So, for the function to be continuous, it should be defined as the same value, the same function, but the function value at x equal to 0 should be defined as a limit value that is coming out to be 7 by 2. So, hopefully this question is also now clearly understood by everyone, how we can find a continuous extension of the function at the indicated point. So, hopefully this question is clear. Let us now go to the next question. Hello friends, let us now start with this next question. So, the question says discuss the continuity of the following function at the indicated point against m. So, it is a very simple question. We just have to discuss the continuity of the function. So, what is the given function? It is root 3 minus tan x upon pi minus 3x when x is not equal to pi by 3, and it is to be taken as 3 by 4 when x is equal to pi by 3, okay. Small printing mistake over here, it should have been just pi by 3. So, x is equal to pi by 3. So, for x equal to pi by 3, the function value is 3 by 4, and when it is not equal to pi by 3, we have been given the function root 3 minus tan x upon pi minus 3. So, we can either use substitution to solve this limit, or of course, we have to use substitution to solve this limit, but we can either substitute in the first step itself, or we can use the value of root 3 to be equal to tan pi by 3, and then use the formula of sine by cos, cross multiply sine a minus b, and then we can make a substitution. So, we can go by any of the methods. Of course, we will get the same answer for both the steps, but in this case it will be better if I just make the substitution in the first step itself. So, let us find the limit when x tends to pi by 3 for the function f of x. So, what is limit x tends to pi by 3 f of x? So, limit x tends to pi by 3. So, f of x is root 3 minus tan x upon pi minus 3x. Okay. So root 3 minus tan x upon pi minus 3x. So let us now substitute for x. So we will say let pi by 3 minus x be equal to, say it is x. So let pi by 3 minus x be equal to h. Of course, we will have to find the value of x. So I can say that is pi by 3 minus h is equal to x. Okay. And when x tends to pi by 3, of course, when x tends to pi by 3, okay, h will tend to 0. Okay. So now we can make the substitution. So over here, where it is written x tends to pi by 3, instead of that we will write h tends to 0. So I will get limit, instead of x tends to pi by 3, it will be now written as h tends to 0. Root 3 minus, now instead of tan x, okay, so instead of the value of x over here, we will have to substitute pi by 3 minus h. So instead of x, I will be writing it as pi by 3 minus h upon, again over here also, pi minus 3 into pi by 3 minus h. So this is the substitution that we have done. Of course, I will have to use the formula tan a minus b now, correct? So we will have to use the formula tan a minus b to solve this question further. So this is now limit h tends to 0. So it is root 3 minus tan a minus b. So what is this? This is tan a minus tan b upon 1 plus tan a into tan b. Okay. So this is what we will be getting, of course, upon, when I multiply this 3 inside the bracket over here, so I will get pi minus 3 into pi by 3, minus into minus will be 3h. So of course 3 and 3 cancels. What is left is pi minus pi, of course that can also be cancelled. What is left is just 3h at the denominator now. Okay. So this is equal to limit x tends to h, so limit h tends to 0, root 3 minus, let us apply the value, tan pi by 3 is root 3 minus, of course tan h will be just tan h, 1 plus root 3 into tan h upon, this is 3h. Let us cross multiply. Okay. So when we cross multiply, we will get limit h tends to 0, root 3 into 1 will be root 3 plus root 3 into root 3 will be 3 tan h minus root 3, minus into minus will be plus tan h upon, okay, upon will be the entire term 1 plus root 3 tan h. So upon will be of course 1 plus root 3 tan h, but this will be with the term at the denominator which is already present, that is 3h. Okay. So what can be cancelled? So we can see that root 3 minus root 3 can be cancelled. 3 tan h plus tan h can be written as 4 tan h, correct? So this is now limit h tends to 0. Okay. So limit h tends to 0, 3 plus 1, that will be 4 tan h upon 3h, and this will be 1 plus root 3 tan h. Now let us apply the limit. So if you check, this is tan h upon h, which is equal to 1, correct? So tan theta upon theta, that value is equal to 1. So the limit value is coming out to be equal to, so when I apply the limit, applying the limits we get, okay. So this is equal to 4 by 3 into 1 upon 1 plus root 3 into tan 0 which is equal to 0. So tan h will be, correct, so tan 0. So what is left over here is just 4 by 3. So this is the limit value that we are getting. What was the function value that was given in the question? It was 3 by 4. It was not 4 by 3. It was 3 by 4. So what can we say? So this is not equal to, the function value at x equal to 0. So therefore the function is discontinuous. So it is discontinuous at the value x equal to pi by 3. So this is how this question had to be done. So we had to solve the limit, okay, but we did not use any other method. We could not use L'Hospital's rule or any other method like that, because we had to solve the limit, actually solve the limit by using the methods of substitution. So hopefully this question was clear. This was the pattern in which we had to do it in the board exams or college exams. Okay. Of course, this question, if it was asked in a entrance exam, we could have used L'Hospital's rule and got the answer much more easily. So hopefully this question is clearly understood by everyone. Thank you for watching this video. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says, discuss the continuity of the following function at the points indicated against them. So just like a similar question that we have done previously. So f of x is equal to 4 raised to x minus 2 raised to x plus 1 upon 1 minus cos 2x when x is not equal to 0, and it is log 2 the whole square upon 2 when x is equal to 0. So this is at x equal to 0, because it should be x equal to 0. So we have to check whether the function is continuous. So we will have to find the limit, and if it comes out to be log 2 the whole square upon 2, then the function is continuous, else it is discontinuous. So let us solve this. So I can say limit x tends to 0 f of x is equal to limit x tends to 0 4 raised to x minus 2 raised to x plus 1 upon 1 minus cos 2x. Okay. So this is equal to limit x tends to 0. Now instead of writing 4 raised to x, let us write it as 2 raised to x its square minus 2 raised to x plus 1 will be 2 raised to x into 2 raised to 1 plus 1 upon this will be 1 minus cos 2x. Okay. So 1 minus cos 2x. Okay. So 2 raised to x square minus 2 raised to x into 2 raised to 1 plus 1. Now this is just like a square minus, correct. So this is like a square minus 2ab plus b square. Correct. So the a term is of course 2 raised to x and the b term is 1. So this is like 2 into 2 raised to x. Correct. So this is like a square minus 2ab plus b square. So let us use that formula. So I can say this is limit x tends to 0 2 raised to x minus 1 the whole square upon 1 minus cos 2x. So what is 1 minus cos 2 theta? That is 2 sine square x. Okay. So 1 minus cos 2x is 2 sine square x. So what can we do? We can write it 2 times, but each of the terms over here like sine square x, for it to be completed I will require upon x. Okay, sine x upon x is 1. So since there is sine square x, I will require 2x, so that is x square. Same way over here also the formula is a raised to x minus 1 upon x. So for both the formulas to be complete, I will have to divide it by x square. Okay. So the formulas that we are going to use is this: limit when x tends to 0, a raised to x minus 1 upon x. This is a log a. So this is one of the formulas. And similarly, limit x tends to 0, sin x upon x. This is equal to 1. So for both the formulas to be complete, both of them needs to be divided by x square. Okay. Let us do that. So in the next step, I will say this is limit when x tends to 0. Okay. So I have 2 raised to x minus 1 the whole square. So instead of writing it as whole square, I will write it as 2 raised to x minus 1 into 2 raised to x minus 1, and I am dividing the numerator by x square and also the denominator by x square. So this is sin x into sin x, and they both are also divided by x and x over here. So I have divided the numerator and denominator by x square. Now this division is possible because x is not equal to 0. So I am not dividing by a 0. Okay. So I am using some number which is very close to 0. It can be like 0.1000 0 and then 1, but still it is a very close value to 0. It is not equal to 0 exactly. So that is what is done over here. So we are dividing by a very close number to 0. So what is the formula for this? Correct. So over here we can see this is just like limit x tends to 0, a raised to x minus 1 upon x, that is log a. So I can use the formula over here. Of course, this is also a formula, log a sin x upon x will be 1. This is also 1. So we can now apply the limits. So we can see that all the formulas are completed. So the next step will be applying the limits. So when we apply the limits, the limit value will be now, of course, the first value was log 2. The second value was also log 2 upon we have this is 2 and the rest of the values were actually 1. So this is log 2 into log 2. So this is log 2 the whole square upon 2. Okay. So log 2 the whole square upon 2. So this is the limit value that we have found. What was the function value that was given to us in the question? See, that was also log 2 the whole square, correct? So this is equal to the function value f of 0, correct? So this is equal to f of 0, which is given in the question itself. So we can say that log 2 the whole square upon 2 is equal to f of 0. So I can say therefore the limit x tends to 0 f of x is equal to the function value at x equal to 0. So I can say therefore the function is continuous. So therefore function is continuous at x equal to 0. So this is the required answer. So hopefully this question is also clearly understood by everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says, identify the discontinuities for the following function as either jump or a removable discontinuity. So when we are saying jump discontinuity, so of course a jump discontinuity is when there is a visible jump happening in the functions. Like for example, a value is stopping, the left hand limit is stopping at say 1 and the right hand limit is starting from say 2. So that is a visible jump and that is a big discontinuity in the function. So that cannot be removed, okay. So such a discontinuity cannot be removed. So discontinuity can be removed if both the values are at least the limit values existing, okay. So if both the values left hand right hand limit are coming at that same point or giving the same answer, then we can say that the discontinuity can be removed or it is having a removable discontinuity. So that is what we have to discuss over here. So identify the discontinuities as either a jump or a removable discontinuity. Okay, so if the limit values are existing but the function value is defined to be something else, so we can redefine the function and the discontinuity can be removed. So that is what we have to do in this type of question. So what we will have to do is we have to first find the left hand limit. So x tends to 4 minus f of x is equal to limit x tends to. Now since I am saying limit x tends to 4 minus, that is when the value of x is less than 4. So when the value of x is less than 4, so what is the function that we have to use is x square plus 3x minus 2. So let us apply the value of x to be equal to 4. So I will get this is 4 square plus 3 into 4 minus 2. So this is 16 plus 12 minus 2, which is equal to 28 minus 2. So that is 26. So this is what we are getting as the left hand limit. Now let us check what is the right hand limit. If it is coming out to be equal to 26, then of course the function is having a removable discontinuity, or we can say it is continuous for the given values. Okay. So limit extends to 4 plus f of x. So this will be equal to limit extends to 4 phi x plus 3. So let us apply the value of x as 4. So this is phi into 4 plus 3. So that is 20 plus 3, which is equal to 23. So definitely what we can see is that the left hand limit is not equal to the right hand limit. We can say that limit extends to 4 minus f of x is not equal to the limit extends to 4 plus f of x. So therefore function is not continuous or function is discontinuous, but this discontinuity is jump discontinuous. So the function is having jump discontinuity at x equal to 4. So this is the answer that we are getting. The function is having jump discontinuity at x equal to 4. It is not having a removable discontinuity but a jump discontinuity. So hopefully this question is clearly understood by everyone. Let us now go to the next. Hello friends, let us now start with this next question. So the question says, which of the following functions are having a removable discontinuity? So there is a small typing mistake. It is removable discontinuity. If it has a removable discontinuity, then redefine the function so that it becomes continuous. So over here, the question you can see that the function is of the type x is not equal to and x equal to 0. So such type of functions will definitely have a removable discontinuity only. It will not have a jump discontinuity possible at all, if it is not having mod or a greatest integer function, something like that in the question. So over here we can see there is no mod function, no greatest integer function in the given question. So definitely there is no need to discuss left hand and right hand limit. So we can definitely say that the function is going to have a removable discontinuity at all. If it is having a discontinuity, then it will be removable discontinuity only. So what we have to do is we will have to find the limit when x tends to 0 f of x. Okay. So what is limit when x tends to 0 f of x? So this, if it comes out to be 3 by 4, then of course the function is continuous. But if it is not 3 by 4, then the function is having removable discontinuity only and no other possibilities there. So limit x tends to 0, it is e raised to pi sine x minus e raised to 2x upon pi tan x minus 3x. So this is what is the given function for us. So what can we do over here? Okay. So this is equal to. So of course, to complete the formula, I will have to write it as minus 1 plus 1. So limit x tends to 0. So this formula e raised to pi sine x. So it's like e raised to x minus 1 upon x. So to complete that formula, I will have to write it as minus 1, and to balance this, I will have to write plus 1 upon. So this is pi tan x minus 3x. So this is what we are getting. So we can see the formula that we are trying to obtain over here is the limit x tends to 0 e raised to x minus 1 upon x. So this is the formula. Of course, this value comes out to be equal to 1, and limit x tends to 0. Over here we will have to write tan x upon x and sin x upon x. All these formulas will be coming. So tan x upon x, sin x upon x. So all these formulas will also be there. So limit x tends to 0, sin x upon x will be also equal to 1. So over here we can see that to complete this formula, e raised to phi sin x minus 1 upon, okay, so that part will be containing phi sin x. Only then the formula becomes to be equal to 1. So what we will have to do is, of course, divide the first term by phi sin x and then adjust for each and every term so that their corresponding formulas will be completed. So this is limit x tends to 0 e raised to, this is phi sin x minus 1. Okay, now to complete this formula, what we are going to do is, okay, so to complete this part, okay, so to complete this part, I will divide by phi sin x, and of course I will have to multiply by phi sin x. So I'll write it phi over here and sin x over here. What else was left? This was minus e raised to 2x plus 1. So this is minus e raised to 2x plus 1. Now to complete this formula also, I will have to divide something. Okay, we will see that later, but for now what we can write is the remaining term. So this is phi tan x minus 3x. So to complete each and every formula in this part, okay, what we will have to do is I will have to divide this by x, correct? Sin x upon x becomes 1. This also needs to be divided by x. This also, of course, I am dividing the numerator and denominator by x. So I will have to divide each and every term by x. So this is also divided by x. X and x will cancel. What is left is only 3. Now a little adjustment in this part as well. So over here I will have to multiply and divide by 2, so that e raised to 2x, that part also gets completed. Since I had taken minus common, I should write it as e raised to 2x minus 1. So this is what we are getting after adjusting all the formulas. So we can see that sin x upon x is going to become 1, tan x upon x is going to become 1. This value e raised to 2x minus 1 upon 2x is also going to become 1. So we can now just apply the limits. So applying the limits we get. So this is phi into, so this entire term e raised to phi sin x minus 1 upon phi sin x, this becomes 1. Sin x upon x becomes 1. E raised to 2x minus 2x upon x, this also becomes 1 upon 2. And this is phi into 1 minus 3. So what is left is phi minus 2, that is 3, phi minus 3, that is 2. So this is 3 by 2, but it is not equal to the function value which was given to us, which was actually given to us as 3 by 4. So what can we say over here? Definitely the function is not continuous, right? So we can say therefore, function is having, like we already discussed, that this function will be having a removable discontinuity only. The function is having removable discontinuity. Okay. At x equal to 0. So the function is definitely having removable discontinuity at x equal to 0, and the discontinuity can be removed by redefining the function as. So of course the function needs to be redefined only for the function value, because the function itself cannot be changed, right? So the function that was given to us in the question, that will be kept as it is. So it is e raised to phi sin x minus e raised to 2x upon phi tan x minus 3x. No changes over here. The function will definitely never be changed. The function value x is not equal to 0. This is going to remain as it is. So what is the function value that we had to take? So it was defined to be 3 by 4, and that is why it was coming out as discontinuous. So we will have to redefine it as 3 by 2, which was the limit value. Now we can say that the function is going to become continuous at x equal to 0. So this is how we can remove the discontinuity by redefining the function. So hopefully this video is also clearly understood by everyone. This question is also clearly understood by everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says the function cos square x minus sin square x minus 1. Okay, this upon root of 3x square plus 1 minus 1 for x is not equal to 0. So if this function is continuous at x equal to 0, then what is the value of f of 0? Since it is given that the function is continuous at x equal to 0, so the function value and its limit value, they both will be same, correct? So what we can say is, since function is, okay, so since the function is continuous at x equal to 0, so therefore the function value and the limit value, they both are going to be equal. So the limit extends to 0. Now instead of the function, okay, obviously we will be writing it as cos square x minus sin square x minus 1 upon the root of 3x square plus 1 minus 1. So what we can do is, we can just find the conjugate of this, so rationalize, okay. So we can just rationalize this denominator so that we can then find the limit quite easily. So let us rationalize the denominator. So limit extends to 0. This is cos square x minus sin square x minus 1 upon 3x square plus 1, root of 3x square plus 1 minus 1 into This is root of 3x square plus 1 plus 1. And this will be root of 3x square plus 1 plus 1. Okay. So this is now a minus b into a plus b. So obviously this is limit extends to 0, a minus b into a plus b, a square minus b square. Okay. So this is 3x square plus 1 minus 1. Correct. So for the square, the root gets cancelled, but minus 1 square will be obviously minus 1. Now instead of writing cos square x minus sin square x, let me just write it as cos 2x. Right. So we can just write it as cos 2 theta minus 1. Okay. Or we can just convert this cos square x into 1 minus sin square x. Even that can be done. Okay. So even that is a possibility that is over here. So instead of writing it as cos 2x and then again getting it as sin square, let us write it as 1 minus sin square x instead. And this is of course minus sin square x, this is minus 1, and this is root of 3x squared plus 1 plus 1. So this is what we are getting right now. So definitely the plus 1 minus 1 part cancels over here, plus 1 minus 1 also cancels from this part. What is left is, okay, so limit extends to 0. We are left with minus 2 sin square x upon 3x square. So this term is now going to become 1. This is root of 3x square plus 1 plus 1. So now when we apply the limit in this part, what are we going to get is, this is minus 2 by 3 into 1. Okay, so this value becomes 1. Root of 3 into 0 because x tends to 0. So this is just root of 1 plus 1. Of course, that will be 2. So the final answer that we are going to get for the limit is minus 4 by 3. So this is minus 4 by 3. So what is this value? This is the value of f of 0 also. So this is the value that we wanted. So since the function was continuous at x equal to 0, the limit was equal to the function value, and the limit value we got was minus 4 by 3. So that is f of 0 as well. So hopefully this question is also clearly understood, everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says, if the function f of x is equal to 4 raised to x minus pi plus 4 raised to pi minus x minus 2 upon x minus pi the whole square, where x is not equal to pi, is continuous at x equal to pi, then find the value of f of pi. So very similar to the question that we have done previously. So over here the question says that the function is continuous. So since function is continuous at x equal to pi, so therefore what is the value of f of pi will be equal to, that is equal to the limit when x tends to pi f of x. So this is limit x tends to pi. What is the value of f of x? That will be 4 raised to x minus pi plus 4 raised to pi minus x minus 2 upon x minus pi the whole square. So what we can say is, we can substitute, let pi minus x or x minus pi be equal to, okay, some value, say h. So I can say let say I substituted x minus pi be equal to h. So what is the value of x? X will be equal to pi plus h. But it won't be required, like even if I don't write x equal to pi plus h, this question can be solved. Now when x is equal to, when x tends to pi, obviously h will tend to 0. Okay, so when x becomes pi, pi minus pi, so h becomes 0. So this is now going to be limit when h tends to 0. 4 raised to h, correct? So x minus pi is equal to, correct? So x minus pi is equal to h. But what is pi minus x then? Obviously that will be minus h, okay, upon this is h square. So x minus pi. So this is what we are getting right now. So a little changes over here. So what we can do is, instead of writing 4 raised to minus h, let us write it as 1 upon 4 raised to h, okay. So I can say this is now limit h tends to 0, 4 raised to h plus 1 upon 4 raised to h minus 2 upon h square. So this 4 raised to h can be cross multiplied and we will get the term as limit h tends to 0, 4 raised to h the whole square, 4 raised to h square, plus 1 minus 2 into 4 raised to h upon this 4 raised to h and h square. So what is this? This is limit h tends to 0 and 4 raised to h minus 1 the whole square upon h square and 4 raised to h. Okay. So this is how the terms can be now adjusted. So you can see that this numerator part was actually a square minus 2ab plus b square. The 2ab part was actually written the second term. Okay, I mean like the third term. So 4 raised to h the whole square plus 1 minus 2 into 4 raised to h. Okay. Now this is equal to, obviously these two values can be now used for the formula a raised to x minus 1 upon x. So this entire part can be taken as a formula. So when we apply the limit in this case now, so upon applying the limits, this will be equal to log of 4 into log of 4, that will be log of 4 the whole square, and 4 raised to 0 is of course 1. So this is the answer that we are getting. So the limit value is log of 4 the whole square. So what is the value of the function then? F of pi, of course that will be also same. So we can say therefore f of pi is equal to log of 4 the whole square. So this is the required answer for us. So hopefully this question is also clearly understood by everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says if the function f of x is equal to 24 raised to x minus 8 raised to x minus 3 raised to x plus 1 upon 12 raised to x minus 4 raised to x minus 3 raised to x plus 1, then for, I mean like this is for x is not equal to 0 and it is continuous at x equal to 0, then find the value of k, where the k value is actually the function value at x equal to 0. So what is given to us is that the function is continuous. So since function is continuous at x equal to 0. Okay. So since function is continuous at x equal to 0, so therefore the function value will be equal to the limit value. Okay. So the function value is equal to the limit value. So limit x tends to 0, this will be 24 raised to x minus 8 raised to x minus 3 raised to x plus 1 upon 12 raised to x minus 4 raised to x minus 3 raised to x plus 1. So these are the values that we are getting. Of course, I can take 8 raised to x common in this part, 4 raised to x common in this part, so that we can get it as a multiple. Okay, so we can get it as two factors that are getting multiplied over here. Now f of 0 was the value of k actually. So I can start writing this as k. So k is equal to limit x tends to 0. Okay, this is 8 raised to x is taken out common. What is left is 3 raised to x minus 1. In the second part, I can take minus 1 common. What is left is 3 raised to x minus 1. Upon, for the denominator, I can take 4 raised to x common. What is left is 3 raised to x minus 1. And again minus 1 common. What is left is 3 raised to x minus 1. So I can take 3 raised to x minus 1 as our common terms. So limit x tends to 0. So we can take 3 raised to x minus 1 as our common term. What is left is 8 raised to x minus 1 upon, this is also 3 raised to x minus 1 and this is 4 raised to x minus 1. What is left over here? So definitely these two terms can be cancelled. To complete the formula, I will have to divide by x. Okay. So now k is equal to limit x tends to 0. Okay, so this is 8 raised to x minus 1 and this was 4 raised to x minus 1, but to complete their formulas I had to divide by x. So let us divide the numerator and denominator by x. So the formulas are now getting complete. So when we apply the limits, in this case k will be equal to log of 8 upon log of 4. Now this can be solved a little more further, right? So instead of writing 8, I can write as log of 2 cube and this will be log of 2 square. So what is this? This is 3 log 2 upon 2 log 2. So log 2 can be cancelled. So what is the value of k that we are getting? So the value of k that we are going to get is equal to 3 by 2. So this is the final answer that we are getting in this case. So this was quite an easy question. It wasn't that difficult at all. So we were getting the value of k to be equal to 3 by 2. So hopefully this question is also clearly understood by everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says, for what values of a and b is the function, the given function, that is continuous for every x on R? So when we are saying that the function is continuous on the entire interval of R, definitely it will be continuous for 2 and for 3. So you can see that the function is defined in this manner. See, there is 2 over here, there is 3 over here. So for the value of x less than 2, the function is having this definition. It is x square minus 4 upon x minus 2. Between 2 and 3, it is having the definition ax square minus bx plus 3. And beyond 3, it is having the definition 2x minus a plus b. But the function is given to be continuous. So that there should be like continuity in this. There is no break over here. The function is throughout continuous. That is what is the given information. So definitely the function is continuous at 2 and continuous at 3. There is a smooth continuity, or there is no break in the function that is going to happen in this case. So let us solve. Okay. So I can say that since function is continuous on every x. Okay. So I can say therefore function is continuous at x equal to 2. So first let us solve for 2 and then we will solve for 3. We will get 2 equations, and solving those 2 equations we will get the values of a and b. So that is how we are going to solve this. Okay. So we can say therefore limit extends to 2 minus f of x is definitely equal to limit extends to 2 plus f of x. So they both are going to be equal. So limit extends to 2 minus f of x is equal to limit extends to 2 plus. So when I am saying limit extends to 2 minus, I will have to use the value where the function is less than 2. So that is x square minus 4 upon x minus 2. And this is limit x tends to 2. So when I am saying 2 plus, that means the value for x is greater than 2. So that is ax square minus bx plus 3. So it is ax square minus bx plus 3. So this is the value where it is x is greater than 2. So now let us apply the limit, and I mean in this case it can be directly applied, but over here it will be the formula, okay, that is x raised to n minus a raised to n upon x minus a. So this is actually 2 raised to 2. So when I apply the limit, it will be 2 into 2 raised to 2 minus 1. So n into a raised to n minus 1, correct. So that is the formula. And over here in this case, I will apply the value of x to be equal to 2. So that is a into 2 square minus b into 2 plus 3. So these are the values that we are going to get. So this is 2 raised to 2 minus 1, of course that is 2. 2 2s are 4. This is 4a minus 2b plus 3. So I can say 4a minus 2b, 4a minus 2b is equal to 4 minus 3, which is equal to 1. So this is the first equation that we have obtained by using the left hand limit and right hand limit at x equal to 2. Now let us solve the same for at x equal to 3. Okay, so therefore, or we can say since function is continuous also at x equal to 3. So since it is continuous at x equal to 3, so the limit when x tends to 3 minus f of x, that is the function is less than 3, is equal to the limit x tends to 3 plus f of x. So this is equal to limit x tends to 3 minus, what does 3 minus mean? So that is less than 3. So for the part less than 3, I will use obviously ax square minus bx plus 3. And for the part where it is greater, so I will get limit x tends to 3. Of course, I will get 2x minus a plus b. So this is what we are getting for the part which is greater. So I can directly apply the value of x to be equal to 3. So when I apply the limits, I will get a into 3 square minus b into 3 plus 3 is equal to 2 into 3 minus a plus b. So these are the values that I am getting right now. So what is this? This is 9a minus 3b plus 3 is equal to 6 minus a plus b. So 9 minus of minuses, that is 9 plus a. So I will get 10a minus 4b is equal to 3. So this is the second equation that we are getting. So it is 10 minus 4, so 10a minus 4b is equal to plus 3. So these are the two equations that we have, 4a minus 2b and 10a minus 4b. So if I multiply this equation by 2 and then subtract, I can definitely get the value of a first and then I will get the value of b. So the two equations that I have is 4a minus 2b equal to 1 and 10a minus 4b is equal to 3. So this is our equation 1, this is our equation 2. So let us multiply this equation by 2. So therefore I will get, okay, so therefore 8a minus 4b is equal to 2. So this is equation number 3. Now let us subtract. So subtracting equation 3 from 2. So 3 is subtracting 2. So I can say this is 10a minus 4b is equal to 3. 8a minus 4b is equal to 2. Subtractions, obviously that will be sign change. So I will get 2a. So 10 minus 8, 2a is equal to 1. So what is the value of a? It is 1 by 2. So since I have found the value of a, let us substitute in this first equation. So it is 4 into 1 by 2 minus 2b is equal to 1. So this cancels, 2 minus 2b is equal to 1. So 2 minus 1 equal to 2b, so value of b is also coming out to be equal to 1 by 2. So a and b, both the values are equal to 1 by 2. So that is the final answer for us. A and b are both equal to 1 by 2. So hopefully this question is also now clearly understood by everyone. Let us now go to the next question. Hello friends, let us now start with this next question. So the question says, which of the following functions has a removable discontinuity? If it has a removable discontinuity, then redefine the function so that it becomes continuous. So the function is defined as log of 1 plus 5x up to the base 1 plus 3x when x is greater than 0. And when it is less than 0, it is 32 raised to x minus 1 upon 8 raised to x minus 1. So now we have to check whether the function is coming out to be continuous or not, or if it is having discontinuity, then is it removable or is it non-removable? Okay. So let us find the left hand and the right hand limit. So limit x tends to 0 minus f of x. This is equal to limit x tends to 0 log of 1 plus 5x to the base 1 plus 3x. So how can I write this? Of course, I can use the property log of a to the base b is log a upon log b. So I can say this is log of 1 plus 5x upon log of 1 plus 3x. Now let us divide the terms, both numerator and denominator, by x. So this is limit x tends to 0, okay, log of 1 plus 5x upon x, and this is log of 1 plus 3x upon x, right. So let us adjust the values a little. So this is 1 plus 5x upon x. So I can multiply and divide by 5. So this completes the formula. I can multiply and divide by 3. So this also completes the formula. So this entire terms, this entire term becomes 1. This also becomes 1. So both the terms, this value is now going to become 1 when I apply the limit. This is also going to become 1 when I apply the limit. So upon applying the limits, so I'll get this is 1 into 5 upon 1 into 3. So this is equal to 5 by 3. So this is what we can say is the left hand limit. Now let us solve the right hand limit, whether it is coming out to be equal to 5 by 3 or not. If it is, then yes, then we can say that the function is having, actually it will be having a removable discontinuity, because the function value is actually not defined. So we will have to define it to be, say, whatever be the value in that case, like 5 by 3 most probably. The limit extends to 0 plus f of x. So let us find the limit. So limit extends to 0, it is 32 raised to x minus 1 upon 8 raised to x minus 1. Correct. So this is the value. Let us divide both the numerator and denominator by, okay. So let us divide both the denominator and numerator by x. So limit extends to 0, this becomes 32 raised to x minus 1 upon x. This completes the formula. And 8 raised to x minus 1 upon x. This also completes the formula. So this is now log 32 and the other value is log 8. So this is limit extends to, so when I apply the limit, this will be log 32 upon this is log of 8. Now how can I write log 32? Obviously I can write it as log of 2 raised to 5 and this is log of 2 raised to 3. So this is 5 log 2 and this is 3 log 2. So log 2 can be cancelled, and what is the value that we are getting is again 5 by 3. So what can we say? Therefore, limit extends to 0 minus f of x is equal to limit extends to 0 plus f of x. So what is the function value that has to be defined is the value of these two limits, since they are equal. So for the function to be continuous, we will have to redefine that the function value at x equal to 0 is 5 by 3. So we can say therefore function has removable discontinuity at x equal to 0 and the discontinuity can be removed by redefining the function. Okay. So we can see that the function that was defined over here, the function was not defined for the value at x equal to 0. Correct. So for that one value, the function was becoming discontinuous. So this discontinuity can be removed. Okay. So the function value was discontinuous right now, but it can be removed by redefining the function as f of x is equal to. So the first one was log of 1 plus 5x to the base 1 plus 3x. This is when x is less than 0. This is 32 raised to x minus 1 upon 8 raised to x minus 1 when x is greater than 0. Sorry, x is less than 0, greater than 0. And this should be equal to 5 by 3 when x is equal to 0. Now the function is going to be definitely continuous at x equal to 0. So by redefining the function for the value, okay, at x equal to 0, now the function is definitely continuous. So hopefully this question is also clearly understood. Let us now go to the next question. Hello friends, let us now start with this next question. So the question is, if the function f of x sine 2x upon 5x minus a when x is greater than 0 is equal to 4 when x equal to 0 and x square plus b minus 3 is this is the function when x is less than 0 is continuous at x equal to 0, then we have to find the values of a and b. So quite an easy question. So we can say that since function is continuous at x equal to 0, so of course the limit value, the function value, all of them should be same. So limit x tends to 0 minus f of x will be equal to f of 0, and this will be equal to limit x tends to 0 plus f of x. So this is what we will be having. Okay. So let us use two of these values at a time. So if I am saying limit x tends to 0 minus, that is the less than 0 part, that is over here, the third part. So I can say limit extends to 0 minus f of x is equal to f of 0. So let us use this for the calculation. So it is limit extends to 0 x square plus b minus 3, and this is equal to f of 0, that is 4. So if I apply the value of x is equal to 0 plus b minus 3 is equal to 4. So the value of b is coming out to be equal to 7. So one part is done. Now let us solve for the second part. So we can also say limit extends to 0 plus f of x is equal to f of 0. So this is also, I mean, like they are also same. So sin 2x upon 5x minus a. So this is limit extends to 0 sin 2x upon 5x minus a is equal to f of 0, which is 4. So of course I will have to adjust the value over here. So I want sin 2x upon, instead of 5x, I want it to be 2x. So I will multiply and divide by 2. This is limit extends to 0. Minus a is equal to 4. So this value is now going to become 1. So on applying the limit, we are getting 2 by 5 minus a is equal to 4. Okay. So minus a on one side, the rest of the values on the other side. So I can say is equal to 4 minus 2 by 5. So that is 20 minus 2, that is 18 by 5. So this is the value of a that we are getting, 18 by 5, and the value of b is 7. So this was also quite an easy question, it wasn't that difficult at all. So hopefully this question is also clearly understood. Let us now go to the next question.